Good morning or afternoon. I'm Eric Schumacher Rasmussen. I'm the editor and VP of Streaming Media Magazine and the program chair for Streaming Media Connect. This is our 7th virtual event, and I'm feeling pretty good about saying we're going to see you live if you care to join us, and we hope you do, at Streaming Media East in Boston in May 24th and 25th to be exact, with the Content Delivery Summit and Streaming Media University workshops on Monday, the 23rd. The program's not up yet, but registration is open, and the program will be up soon at streamingmedia.com/east. But we are in the midst of another great week of virtual sessions, concluding on Friday with a workshop called The Best Streaming Gear and How to Use It. As always, all of these sessions will be available on demand after the fact if you're not able to make any of them live. Just for being here, you're entered into a drawing to win an Amazon gift card. We'll be announcing the winner at the end of the hour. And I'd also like to thank our diamond sponsors, Bird Dog and Harmonic. And we'll be right back after brief video messages from them. And I'd like to thank the sponsor of this panel, Millicast. And Millicast Ryan Jespersen will be joining us in just a moment. Before we jump in, though, a few housekeeping notes. If you do have questions for our panel, please put them in the Q&A tab at the bottom of your Zoom window rather than in the chat. That just makes it easier for us to keep track of them and for the moderator, Tim Siglin, to pose them to the panel when they come in. And subtitles or transcripts are turned on. If you want to turn them off, you can go to the live transcript button at the bottom of your Zoom window. Click on that and click on disable transcript and they shall go away. So Tim Siglin coming to us from the Help Me Stream Research Foundation lab/office down in Tennessee. How are you, Tim?
Doing well. Not distilling moonshine today, actually just taking apart old computers.
Not today.
Not today.
Anything could happen, though.
That's true.
All right. Well, I will pass it on to you to talk about low latency, ultra low latency, ultra mega super hyper low latency, and all those things.
Sounds good, Eric. Thank you.
Right.
And thank you to our panelists. You know, latency obviously is a topic that comes up every time we do Streaming Media East, West, Connect, Forum. You know, it's a topic that's always top of mind, especially as we move more and more toward live streaming being dominant as opposed to on demand. Ryan, since Millicast is a sponsor, I'm going to start with you, and I'm going to just pose a question to you, and then I'll come to our other two panelists. But you've lived in Europe, and so obviously you've seen sports wagering. You know, you split time between the U.S. and Europe. So, what was your thought around the Super Bowl with crypto and wagering, and where does low latency come into play in something like sportsbook?
Hey, Tim. Hey, everyone. Great to be here. And yeah, I think like you guys mentioned, we actually just recently got acquired by Dolby, and we're part of the Dolby.io team now. So yeah, my words are on behalf of Millicast and then Dolby at whole as well. So yeah, I think with live betting and gambling, I think it's quite an interesting use case for low latency, and what you're going to see a lot of low latency applications coming out, especially in the next 12 to 24 months in the United States. I think there's this intersection of technology now and business opportunity. And with New York just legalizing online gambling in January, I think we were talking before the call, I think it's about $1.6 billion they generated, really in less than a month. So that much money means there's going to be a lot of technology to go try to capture that value in the market. You know, Europe obviously has been a lot more accelerated. Regulation around betting and gambling is quite widespread across Europe. I think US, especially as it relates to sports, it's been very much something that's been taboo in the United States, but that's going to change. It's going to change very, very quickly and aggressively. And I think as it relates to low latency, obviously any room for fraud when there's any, I think there's a couple of use cases for what we call ultra low latency or anything under a second. I think one is you need interactivity between users, communication APIs or media APIs that make you do things very, very quickly. I think the second piece is when you need to have a business need for that. And I think live betting and gambling, you need to remove fraud. And the only way to do that is speed.
Okay, fair point. Andy, we'll go to you next. Introduce yourself, tell us a little bit about what you've been doing. And then I've got a question for you on enterprise.
Sure. So Andy Howard, I'm founder and managing director of Howard & Associates, which is a consulting company that helps organizations implement streaming media or video communications overall, but mostly streaming media, video conferencing, digital signage, things like that. And from a low latency perspective, I have done a couple of projects. I did one project for a auction company. This was probably 8 years ago, where their goal was actually to get the latency under 2 seconds, which seemed pretty difficult at the time, but we were able to accomplish that. And I think they've moved on to some lower latency solutions now. And then I more recently did a project for CSX, which is a transportation company, which they have tons of surveillance and they want to be able to view it, basically in real time. So that's a need. And then, a lot of the business from a streaming perspective in corporate communications comes from, executive broadcasts and other live events that organizations are having. And more frequently, I think people are wanting to be able to have the audience participate in those events, whereas somebody can actually ask a question over video or audio rather than using the chat, which obviously requires lower latency than what most of those people are putting out. So those are kind of some of the things that my background that'll help out here.
And that was one of the questions for you. So enterprise, typically has been really comfortable with 10 seconds. You do your Q&A or polling by chat. Is there a trend now toward trying to get that bidirectional latency down so that it's more like a massive video conference or a Zoom than it is a stream that also has this out of band polling and chat?
Yeah, I think there's two. I think the size of the event kind of matters in many cases. So if it's really a company-wide event and there's 10,000 people viewing it, they might be less comfortable with that just because it's more difficult from a technology perspective to pull that off. Some of the smaller events, though, I think people are seeing with some of the tools, even Zoom or Microsoft Teams, you can do it's by definition low latency because they're using the same technology generally that they're using to do the meetings, and so it is possible that you can actually have Q&A, and I think people are starting to dabble in that a little bit. I actually just saw an event the other day where they did that, and it was probably the first one that I've seen. I know a lot of people are asking about it, but I think it's going to be a trend that's definitely going to increase as time goes along.
Okay.
Because it was just too difficult to do before, but now with the technology there, that I think people are going to want to do it once they figure out that it's possible.
Sure. All right. Good deal. We'll come back around to enterprise in a minute. Michael, introduce yourself quickly. Tell us just a brief about Caffeine, because this is a company I wasn't necessarily familiar with.
Sure. Yeah. So I'm Michael. I head up engineering at Caffeine. Caffeine is a sort of social live streaming platform, kind of similar to Twitch, but sort of with an emphasis on street culture content and sort of other and gaming as well, but sort of specializing in sort of low latency experience with the WebRTC CDN in terms of encouraging sort of real-time interactivity among participants and broadcasters.
And is that real-time interactivity bidirectional audio and video, or is it chat?
Today it's mostly chat. We've played around with sort of co-hosting formats, and we've thought a little bit about doing sort of call into stage type flows, but presently it's the primary interactivity form is with chat.
Sure. Okay. So one of the things that I want to sort of level set and get a response from each of you on is, what do we consider low latency? And Ryan, I know, of course, we did the research together that we presented a few months ago, where most people were saying acceptable low latencies were in the 2 to 3 second range. You mentioned ultra low latency, which, you know, we would call sub 1 second. I worked in video conferencing where we would call it sub 250 milliseconds. But I'll start, Michael, with you. Kind of define what you mean by low latency, because an audience member's already asked that question, and it's a valid point.
Yeah, I think the sort of the industry is standardized around sort of ultra low latency being sub-second and low latency being like 3 to 6, let's say, and then just standard streaming being the 15 to 30 or so. I think those are useful ways to think about it. In the case of Caffeine, it is a WebRTC CDN, so it would categorize as the ultra low latency for that flow, though we are kind of increasingly using low latency streams for our very, very large shows where it has less of a differentiating experience at play.
Okay, that makes sense. Ryan, what about you? How does Millicast and Dolby sort of see those bifurcations?
Yeah, I'll reiterate what Michael said. I think we're WebRTC CDN as well, and WebRTC platform end to end. So as far as Millicast, we add about 100, give or take, milliseconds to the workflow. The rest is the dirty internet, right? So it's the inbound, outbound, and the question actually from one of the attendees asks, we're doing this in a closed network, or are we doing this over the open internet? And obviously at the open internet, then at that point, the quickest you can get into any kind of a cloud service, the faster those pipelines will get you to where you want to go forward and back, right? So we tend to see, close to our origin edges, no more than 500 milliseconds end to end. So that's what we define as ultra low latency. It's really it's the same as human connection. That's really how I see it when it relates to media and to video. Well, what are we trying to do? We're doing video and audio, right? That's why we're here at Streaming Media. And so we're not here trading finances and there's billions of dollars getting lost in 10 milliseconds of difference between different networks. We're here working with media, and we're trying to create the human experience. And I think getting under a couple hundred milliseconds that's when the human experience doesn't falter from the apps we're trying to build.
Fair point. So Andy, from a enterprise or sort of non-entertainment standpoint, what's your general sense in that part of the market? Do people expect now to have Zoom levels of interaction in the sort of sub 250 millisecond? Are they good with something in a second range, or are they still much more comfortable with that 10 seconds that you initially talked about? And I think you're muted, possibly. There you go.
I should know that. No, I would agree with the definitions before. I would say, the ultra low latency is, less than a second, which, allows for interactivity. And sort of standard low latency would be in anywhere from the 2 to maybe 10 second range. But you even see, like, some of the streams are still 30, 40 seconds, even up to a minute. So if you want to have any sort of interactivity, that you got to get into at least the low latency range. And if you want to have two-way interactivity, I think that's where you have to get it under a second. But I agree with, video conferencing typically talks about under 250.
So you mentioned the CSX scenario, and you described that before the call as being essentially streaming the surveillance cameras from the rail yards, and needing to have low enough latency so that somebody who's coordinating on the ground versus an exec who's sitting in their office, what kind of latencies were tolerable there?
Well, so they were using more traditional streaming technology. So they were seeing like a minute. So if somebody was at home, for example, watching their surveillance, but somebody was in the office and they were also watching that, the difference would be considerable, which caused issues in terms of, how do you coordinate when one person is watching something that's a minute behind what somebody else is watching. So that's where the desire to get to lower latency solutions comes from. And I've seen that in sports too. That if you're trying to watch back in the pandemic, the early stages of the pandemic, when they had the NFL draft, which was like the only sporting thing that was happening. I was trying to watch it, on Zoom with my friends, but one person had YouTube TV and he was like a minute and a half behind everybody else. So everybody else had to like change, manage their DVR to try to, sync it up so that it was around the same amount of time as he was. So, when you are coordinating things with different people, it does make it challenging when the latencies are significantly different.
And that leads to a question that I had posed to all of you before we came on here: is what's more important, synchronization or latency? And you've mentioned, Andy, sort of your take on that, but I want to open that up to Michael and Ryan.
Sure. So I think it really depends on the show format, right? Like if it's interactive voting and the talent on screen is incorporating the running tally of the vote in real time as he's reacting to it, then certainly, ultra low latency has some use cases there. But if it's sort of being relayed over a headset for them to announce the winner, doesn't, then 3 to 5 seconds, totally fine. So it really depends on how in our case, these are sort of like competitive rap battles or competitive dance competitions or competitive skateboarding competitions. These are, and there's an audience voting element to the show. And so how that actually gets incorporated into the format of the content being broadcasted on the platform really dictates, the level of latency that is really necessary.
Okay, Ryan?
Yeah, to add to Michael's point, I think it depends on the use case. I think as we talked about low latency, what are we talking about? Are we talking about contribution? Are we talking about all of us working together on content in real time? Or are we talking about distribution? I think there's 3 different pieces where that's key. Some of the questions we're getting are, as far as the contribution side, how can we use WebRTC for encoder workflows and high quality workflows, and how can we add the interactivity piece like we can in Zoom while still retaining the broadcast quality that we want in the contribution side? I think what you're seeing a lot of is WebRTC is doing a lot on that side from a client SDK side and trying to build that workflow, those workflows into encoders. The other part that I think is very compelling is the actual using the cloud as the mixer for now doing these new advanced workflows. We had BirdDog as a sponsor, right? And congratulations to them. They went public on the Australian Stock Exchange about a month ago. And with BirdDog, obviously they're doing NDI, but we worked with them actually doing NDI to WebRTC transmixer so that people could now mix NDI BirdDog cameras in the cloud using WebRTC and then distribute over a WebRTC CDN. And then there's that part, which is a distribution part. And I think, obviously I'm pitching WebRTC here. I think WebRTC can be used end to end for contribution, mixing, and distribution, keeping the native protocol end to end. I think the beautiful thing about WebRTC is that it is by default, over UDP, it prioritizes latency over anything else. It would rather drop packets than take any more time. And I think as people talk about SRT or they talk about other HTTP protocols or even RTMP, these are TCP protocols that actually try to mimic, especially with SRT or ZXC, they try to mimic the resiliency of TCP, but while still trying to act like UDP. The reality is if you want speed, you've got to drop packets on bad connections or find a way to adaptively adapt the encoding at source, and that's what WebRTC does natively. So there's something beautiful about that workflow that I think, and then I think as WebRTC kind of matures, now people are building broadcast quality tools around that to actually do the contribution side as a way to replace it. So sorry, that was a long-winded response.
No, and you hit a couple points that we'll come back to, RTMP being one of them. Somebody asked a question from the audience, and you sort of answered this, Ryan, by mentioning NDI. I'll open this up to Andy and Michael. What else besides WebRTC is being utilized? Are NDI tools being used because of their low latency? So let's open that up.
Yeah, from my perspective, NDI has been, extremely popular on a sort of a local area network, because the bandwidth's still pretty considerable to be able to send it over the internet. From people using contribution over the internet, SRT has been pretty successful from my perspective. I've seen a lot of people using that, with their encoders. You send an encoder, whether it's hardware or software, out on site, send it back to the to the production over SRT. That works phenomenally well. In terms of the video conferencing solutions, they typically do not use WebRTC, except when you're trying to interact with between two competing things. Like, so if you're in a WebEx video conferencing room and you're trying to join a Teams room, it'll typically use WebRTC to make that translation. But otherwise, like Zoom, for example, I know there was a question on this. Zoom uses scalable video coding, which is basically it's kind of like adaptive bitrate streaming, where there's different layers in the video, and based on the bandwidth and the CPU and things like that, it'll drop down to a lower level based on what you have available to you. But also extremely low latency, because that's always been a consideration for video conferencing providers.
Yeah, and I'll add to that, SVC was one of those things that came along shortly after H.264 moved into the streaming world. I'd used it in video conferencing for years before I moved into streaming. SVC had a really good idea, but it never took off. And part of that was the sort of 265 was on the horizon. Maybe we'll get to 265 and it'll do things better for us. But that's a good reminder, Andy, that SVC is one of those things that works really well when it comes to things like this, where we need bidirectional, and we, as Ryan was saying, need to prioritize time over quality. So Michael, from your standpoint, besides WebRTC, I mean, what other options do you see out there as you're looking at low latency? And ignore RTMP for a minute, because I'm going to come back to that one.
For ingest or for distribution?
I would say both ingest and distribution.
So for ingest, I mean, we found it a little challenging, especially for remote sites where it's over cellular connections. Mm-hmm. Like the SRT, we're looking towards more SRT for our produced content, though certainly UGC is coming in through WebRTC ingest. For the distribution, WebRTC, as mentioned, it really prioritizes latency over quality, and that may not be the most critical thing for like a high action sports game type scenario where you really need, you don't want to miss the wrong frame or skip over the something that's critical to the game as it's happening. So we there and any large show where you have the economies of a fully established traditional CDN, make it so that it's, if you can use that infrastructure with reasonable latency relative to the content format that you're leaning into in terms of what you're producing, then by all means, that's a great solution. But also, we're also want to pioneer new and fun interactive loops with that ultra low latency that opens up new possibilities. So we're looking at that as well. Yeah, but so anyway, like low latency HLS, low latency dash, we have a consolidated CMAF origin server that, I don't know how technical we want to go here, but we kind of service both protocols through a single origin of CMAF segments.
Yeah, and that makes a lot of sense with the way that CMAF can be handled both by dash and HLS. So I'm going to come back up to a high level real quick and just throw out a question that I had had set up before the call. So we've talked about auctions, we've talked about sportsbook. What are other market verticals that really would benefit from ultra low latency? And let's keep it specifically at sub 1 second. Andy, you described one with what the CSX guys are doing for surveillance. What are some other market verticals? Because to me, when people come and ask me about ultra low latency, I ask them about their market, and they tell me, and then they have to explain why they need it. It's almost like they want to use it and they're looking for justification to use it sometimes, but they may not necessarily, to Michael's point, need it. Quality may be more important, etc. So I know that's a long rambling question, but let me throw that out to the three of you. Besides the sort of big ones of auctions and sportsbook, what other market verticals could really benefit from ultra low latency?
Yeah, I could take a stab.
I would say medical is another one. There are examples of where people do. You might not be participating in the surgery, but you can watch the surgery and potentially be considered an expert. Not witness, but an expert. Another person that could comment on wow, what's going on here. That's always one. Surveillance. We talked about that. It's not just building surveillance, but it might be military surveillance. Anytime you really need to know what's happening on the ground in real time, crisis communications, things like that. So yeah, I mean, those are a couple that I've thought of, but these guys probably have much better additional examples.
Yeah, Ryan, go ahead.
Yeah, I was going to say that I think they're the traditional ones. So I think we can kind of skip talking about those because I think everyone knows where you need low latency. I think the exciting ones where, what are we trying to do? And COVID and the pandemic and everything has proven this to us. There's new markets that have just popped up out of nowhere. I mean, regardless of your personal thoughts of what Facebook has done to pivot to Meta and what they're trying to do with the whole metaverse, this is one of the largest companies in the world that is putting all their chips in on the idea of a metaverse experience. We have a lot of live virtual hybrid event customers, digital event customers that are trying to build, recreate the human experience through the web, right? And media and video and audio, the way to do that. So one of the things that we've done is build plugins for Unreal Engine. So people building Unreal Engine virtual worlds, they need it to be bi-directional. Unreal Engine was able to buy this company and build something called the Pixel Streaming plugin. We can take that WebRTC out from that local network, scale it, and make it bi-directional. So you can play it back inside of Unreal as well as stream out of Unreal. That is now creating these bi-directional workflows that we're getting people building integrations with like Snapchat to pull in someone's Bitmoji into a live virtual environment or a virtual concert, or their live video camera, pulling that into, there's some very, very cool use cases when it comes to that. And those are just at the infancy of kind of this evolution. And obviously Google with their Stadia platform, gaming is enormous. Everyone's trying to get into that, and they're trying to build bi-directional workflows to create interactivity in gaming through WebRTC. The web is a thin client, and all the computational stuff is happening in the cloud, and WebRTC is a way to enable a thin client interface through a web browser. So I think there's going to be a lot of evolution in that space with the gaming world specifically.
Okay, so gaming, got it. Michael, what about you?
In terms of the
in terms of market verticals,
besides, we ourselves are kind of a unique market vertical, I would say, like in terms of low latency for sort of this interactive social streaming use case. More broadly, I think there's some interesting debate as to the value add. Like you can certainly get a lot more reliability and higher quality if you have shared presentation time, if that's the use case that you're targeting, right? Like if you don't necessarily need glass to glass in some use cases where you're just sort of like, for instance, commenting on a live broadcast that doesn't have those interactive elements built into the format itself in terms of audience participation. So in terms of other verticals, I think sports obviously really important for ground truth to be close to the time the person's watching it, so that you can get a few more seconds of betting in, inspecting the horses or what have you. But I don't know. Like, I think more broadly, WebRTC obviously is exploding in terms of bi-directional communication. But like, if you limit it to the media vertical, like, it's kind of a weird question in the sense, like, how does traditional media adapt to be not traditional media? Like ultimately the new sort of forms of communication are coming about that leverage WebRTC. And if you look at like, the traditional broadcast mindset, then, of course, there's perhaps not as many intuitive ultra low latency requirements coming from there.
Oh, all right, got it. And I heard from at least two of you that new markets are coming into play that are enabled by low latency, ultra low latency, that weren't necessarily enabled before. Okay, that makes sense. Now, somebody asked the question, what's the cost difference that we can expect between low latency and ultra low latency? That is a really good question. And I'm going to toss that out to anyone who would like to take that.
I'll take that. I've pitched this a few times on different streaming media calls. We had back in the RTMP days, right? And I think what we're really trying to replace is what Flash fixed, almost 20 years ago. But they had the benefit of being able to go point to point without having to change. They could control the client, right? The minute the Flash playback client and actually encoding client was removed from browsers, that's the beginning of the end, because you can't control the source to playback, right? But as it relates to cost, we are going back to a model of stateful origin server or server edge connections. The reason the industry is so, especially CDNs, are so invested in the HLS workflows because it's so cheap to scale. It's incredibly cheap because it's stateless files that just sit there and you can just throw CPU resources at it, or not even CPU storage resources at it, which is the cheapest thing you can do. The minute you have to create some kind of a stateful connection, you need to find a way to create this origin edge network, which is expensive, complicated, difficult to scale. It's true of WebRTC. It was true of RTMP. Anyone who tried to build an RTMP, and so you have like Akamai and many more that have deprecated their RTMP edge networks, right? And this really Limelight was the last one that was left, and they've even deprecated theirs now. So reality is we're going back to that. But the thing I want to talk about when it comes to cost is we've gone down to this, 2 cents per gigabyte, 1.5 cents per gigabyte, this kind of race to zero with the commoditized nature of HLS and HTTP streaming. The difference is, like at Millicast, we have customers paying us $1 per gigabyte on our standard plan. If you tell that to a CDN vendor, you're like, what? You know why? Because there's value. Not every piece of bandwidth is created equal, because you're adding value to it. Interactivity to a gambler, to someone doing virtual production in Hollywood, that's worth $100 a gigabyte, and they're getting it for $1. We're not trying to do an HLS CDN of this one-way content. We're doing a two-way interactive thing. So when people talk about cost, you have to not look at it as, oh, look, HLS is worth this and WebRTC is worth that from a CDN perspective. You're not comparing apples to apples. You're comparing completely two different things. I think that's the piece that the industry is not getting. You're uncommoditizing bandwidth as it relates to media. That is an interesting concept, and how we wrap value around that, enabling broadcast workflows through a thin client. That's the piece where there's an enormous value of not having to send 1,000 people to produce the Super Bowl. You can send 5 people and do everything else virtually.
Yeah, and actually, having come out of video conferencing, you make a valid point that, especially if we're talking ultra low latency bidirectional, it is a completely different model from a pricing standpoint than it is. In fact, back then and even now, it's number of seats or number of ports that you used on an MCU. And ultimately, for those who needed it, they paid the price. And that's what I hear you saying, is that for something like Sportsbook, they're willing to pay the price because it pulls the fraud potential down, and B, it allows for many more people to actually place bets closer to real time or ground truth. So, okay, interesting. Michael, Andy, from a cost standpoint, and Michael, you mentioned that you do some things with HLS and Dash low latency, and you do other things with WebRTC. Where's the balance as you begin to have conversations of the cost of what it takes for you to deliver the stuff that you deliver?
Yeah, and I mean, I think if the show format necessitates it, I think it's totally, a worthy investment to, especially in the competitive landscape that is live media experiences on the internet. So like, I think, there are places where it does add that differentiating value, and by all means they can lean into it. I think but if you're just sort of running a stream and trying to monetize on it, through sponsorships or just traditional models, the sort of free distribution over a WebRTC network eventually becomes quite costly relative to traditional CDN distribution. you know,
And you mentioned earlier scale was one of the factors that came into play. Where's sort of that sweet spot where it moves from being valid under WebRTC versus?
Well, I mean, we've done massive. I mean, we've done very large, like, and I'm sure Millicast as well. It's done very large broadcasts over WebRTC. I think, and so we've proven out it is possible. It's just the question, you know, not always a question of if something's possible, but rather does it make the most sense for that use case, right? And that's kind of where we've fallen now to sort of more intelligently choosing our delivery protocol based on kind of the use case of the show itself. Yeah, so I think, yeah, it definitely factors in, and we're talking 100K CCV and up type.
Okay, got it. Good clarification. Andy, what's your general sense on the way
Yeah, I think, you know, from the enterprise perspective, a lot of the CDN capabilities are bundled into the provider that they work with for internet-based CDNs. I think one of the concerns I know that a lot of clients have is that, you know, they've built out their sort of enterprise CDN or, you know, eCDN capabilities internally, and will those work or not work with some of the new capabilities of ultra low latency. So, you know, because they're traditionally HTTP caching devices or stream splitting devices. I think it's also a concern, you know, if they don't, the big concern is that, you know, we're almost rewinding back to, you know, the early 2000s when those weren't in place, and then you're doing, you know, you're like, well, we did a 5,000 user broadcast when everybody was at home, and that was all going over the internet, so that worked perfectly fine. But when those 5,000 people are now back in an office and they're all individually, you know, pulling down a separate connection from the cloud, which didn't used to happen before, that is a ripe opportunity for a lot of networking problems within the internal bandwidth.
makes you sort of yearn for the days of RTMFP, which was pierce the firewall and then replicate in peer-to-peer. So Ryan, we've sort of touched around RTMP, and when we did the study, you know, a couple of months ago, and then when I did the market validation of Wowza's solution as well, you know, one of the things that they gave me feedback on was people requesting RTMP still to be able to feed that through OBS as opposed to doing, you know, sort of straight up WebRTC. And I guess the question I've got is RTMP living quite a bit longer than we expected? You mentioned the CDNs deprecating their, you know, their platforms, but ultimately, does RTMP have legs, and where do RTMP and WebRTC coexist?
Yeah, I mean, I think RTMP defines streaming media, right? And I think it's to a technology to live for almost 20 years in this day and age is unbelievable. RTMP is still the most widely used contribution protocol in the world, and will be for at least another couple of years. Mm-hmm. The problem is that's where it stops. It's only a contribution piece. And when we compare what we're trying to build now, is we're trying to build a point-to-point contribution, mixing, and distribution protocol that never has to leave that protocol. It never has to be transmuxed. It can, because then you can retain all the value point to point. Okay. A lot of the stuff that we want to build around these workflows are actually not even in the video and the audio, they're in the data channel. The minute we have to go from one protocol to another, we lose all of that control. Just think of what we're trying to do with all these RTMP features, and then we have to pull them into HLS. So we have servers like Wowza and others that do all that translation, right? To add that value and translate that value through those little transmuxers or translators. I think when it goes back to talking about SRT and NDI, and they were always built, SRT is a great protocol, but it's a contribution protocol. It never will be a distribution protocol. What we have to learn with RTMP point-to-point is there was one vendor at the center of it. And there was another vendor, Apple, that put an end to it all, right, with the iPhone from a distribution side. We need to recreate that, but we need to recreate that using internet and web standards that are here for the foreseeable future. And I don't think there's anything else that does that outside of WebRTC from contribution, mixing, and distribution. And I'd love to see, there's a lot of questions around encoder maturity with WebRTC, and it's little by little we're getting a few software encoders now adopting that. The minute we start getting a lot of hardware encoders built on WebRTC and standardizing the signaling protocol with WIP, the more you're going to see those point-to-point use cases that allow us to use SVC end-to-end, allow us to control the data channel and standardize the data channel end-to-end. That's the piece where I think it starts becoming a very compelling use case for WebRTC specifically.
Okay.
And truly replaces RTMP end-to-end.
And somebody brought up an interesting point here, sort of in the form of a question, do WebRTC and other formats maintain closed captioning and ancillary data all the way out to the edge user? That was sort of to your point about the data channel itself having that as much value as the video and audio side.
Yeah, just real quick, because I want to leave room for everyone else to discuss is, we're trying to compare WebRTC to RTMP or HLS. RTMP has been around almost 20 years. So it has a maturity level that it's not quite fair to compare. The other side too is RTMP was designed for broadcast and for streaming. WebRTC was originally designed for web use. Now as it's maturing, it is becoming a broadcast contribution protocol. Sure. You have I have a ton of broadcasters who use us for live contribution with WebRTC. So as now more encoders at the client side or at the client side level start building in the maturity level, that's where we need the broadcast industry to start adopting it, because then we're going to start be able to compare apples to apples between one protocol and the other.
And I'll add too, again, coming to the video conferencing world where we did ISDN lines and PRIs, it was fascinating to watch how remote contribution from satellite studios, say for a regional broadcaster, would actually literally just dial up a video conference to send it straight in. WebRTMP or WebRTC feels like it's sort of falling into that model now too, from a contribution standpoint. So, Andy, Michael, RTMP from your standpoint, as Ryan said, it's mature. It's sort of been surprising to me that it's hung on as long as it has. And we had a comment from somebody saying it's not going anywhere. What's your take, Andy and Michael?
Yeah, I agree with Ryan. It's, contribution is still out there quite a bit, but I don't know anybody that's streaming to end users over RTMP anymore. It's been totally overtaken by HLS and some of the other newer stuff that's out there. But to get from your source to a production studio or your cloud-based solution, in many cases RTMP is still the best way, because like Ryan said, it's mature. That encoder A is going to be able to work with production equipment B, and it's all going to work, whereas some other stuff sometimes you might have issues. But I think over time, with the success of WebRTC and SRT and NDI, that'll probably just sort of slowly go, and then there's a tipping point where it just sort of goes away.
All right, Michael, from your standpoint?
Yeah, we're looking forward to, interestingly, Caffeine was built with WebRTC ingest first, so we never really supported RTMP. So we have some sort of gateways that get it into the system today that run externally from our platform, but we're looking towards SRT in terms of for production ingest going forward, and then obviously continuing to lean into WebRTC for UGC and prosumer shows.
Okay, got it. Let's see, we had a couple other questions on here. Somebody asked a question, this is a good one, with contribution across WebRTC and then potentially delivery across WebRTC, where you're looking to lower the latency for live in-event wagering. What happens, what's the impact of ad insertion? Does it add additional latency because we're essentially having to wait for it to, for the playlist to go, okay, now I'm ready to play the next video, which happens to be a pre-recorded commercial?
I mean, there is some maturity happening with server-side ad insertion at the WebRTC level. It still hasn't been defined as a standard. I think one of the big things to talk about is standardization. WebRTC has been adopted as an IETF and W3C standard, as opposed to SRT or NDI or the protocols that have maybe one vendor at the center of it, right? And it's not an open standard. With that in mind, obviously standardizing things takes time, right? So there's a lot of some things happening around server-side ad insertion with WebRTC. To be honest, I've not seen anyone who's adopted that, but a lot of it can be controlled at the client-side level. So obviously you're doing everything natively in browser. So if you do, develop, and I think this is part of the migration of going from AV engineers to streaming engineers, now going to developers, which is really where the industry is going. It's a very developer focused community. A lot of that stuff can be controlled at the client level in browser.
But what's interesting about that, just to devil's advocate slightly, the whole reason we went to server-side ad insertion was to deal with ad blockers of client-side ad insertion. Does that take us back into that problem if we sort of go, we'll just handle, plan commercials that will appear in the client side?
Yeah, and I said that there is some work being done in server-side ad insertion, so that is on the roadmap for WebRTC. The client side, yes, obviously there's different ways to do that, as opposed to how it was done before, which is rendering it to an HTML page that could be blocked, or actually blocking the actual HLS call to go get an ad from a different provider. But yes, you're right. Obviously, as technology evolves, people are going to find ways to block it at the client side level.
Yeah, which is okay. So I guess I may have missed what you said about the fact that SSAI is coming on the WebRTC side. Okay. Anybody else want to add anything to that on ad insertion?
Well, I mean, only that most consumption is moving away from web, where you have that sort of flexibility to begin with in terms of the ad blocker situation.
Mm-hmm. Because you're going to apps.
You're streaming to the Chromecast or the TV or the phone or any native context.
Okay. All right. Got it. So Andy, back on enterprise real quick. When you mentioned that about doing an open internet 500 person event and then people coming back into the office, what's your general sense on hybrid meetings for enterprise? I mean, we've all talked about this with trade shows, maybe as sort of the fallback that you go to if you can't have a live in-person event or a large scale live event. But what about in the enterprise space? Are hybrid meetings coming into play? And if so, where does this low latency delivery come into play?
Yeah, I mean, hybrid events are definitely going to be probably the main type of event. I mean, well, hopefully soon there will actually be people back in offices, but there's still going to be a large number of people that are remote. So it's a big challenge for sure in the video conferencing world, where our conference rooms are not set up for these hybrid type solutions. We always used to do just internal calls. Nobody ever was remote. It's the same thing with streaming. I think most people have figured it out, because it's certainly, they figured out how to send content out to the internet, because I've had to do that by default for the last couple of years. Being able to deliver it back into your enterprise environment is still relatively straightforward, but with a caution that the enterprise networks have changed significantly. A lot of people got rid of their sort of MPLS networks and are going to it's called SASE type environment, where basically every office has a direct connection out to the cloud. That does require some network re-engineering in terms of your ECDN. Does multicast work in that environment? If I'm doing peer-to-peer, how do I need to set it up so that only the peers in a certain office are going to share content with each other? So I think for sure hybrid events are going to continue to be the norm, and enterprises need to figure out how to handle that from a networking perspective.
Okay. And then I've got two final just quick questions from the audience, and then we'll come back to one that I had. One question was talking about new platforms for ultra low latency and how security is handled at the end user. I know one of the big issues we've had with live events, so we still have had over the last couple of years, is the authentication servers crash at the beginning of a pay-per-view fight, and suddenly 25% of the people can't actually come in and watch the fight not because the video delivery can't happen, but because the authentication piece is there. As we're talking about dropping latencies, we're talking about needing those authentication solutions to work a whole lot faster with potentially a much bigger spike in the number of people who need to be authenticated. So Ryan, Michael, any thoughts from that standpoint?
I mean, we're all building solutions in the cloud. I mean, when Salesforce went down, a couple of years ago, half the internet that uses Salesforce to authenticate users to let them into their service, their SaaS service, well, they weren't able to authenticate. They weren't able to capture revenue. And I think that's just the reality of building solutions in the cloud, right? So yeah, as you build into different APIs, so a lot of those APIs maybe aren't built to the scalability to support, peak events. So it's not just media that needs to scale. Media, I think, is the hardest to scale, but there's so many interconnected pieces of tech these days that are all part of creating a turnkey solution. Hence why the focus, I think, is shifted towards developers. Most of the customers we see now in Dolby.io sees and Millicast sees are developer first, video a distant second. They're not video engineers. They're trying to build a solution, and video just happens to be one component of it.
Okay, fair point. Michael, from your standpoint, I mean, do you all have authentication that people have to go through?
Yeah.
And do you run into problems when you go to scale?
Yeah, I think there's numerous microservices involved in creating the experience, including sort of the real-time chat component, which has to handle quite many thousands of requests per second, and the WebSocket connections to translate that state to all the clients in real time and everything. There's a whole host of services and systems in place that need to all work for the experience to be what we're trying to deliver. Though, I think the WebRTC CDN has proven the most tricky to scale, because you can't really put it out. You can't really run it in an AWS native environment because of costs, because it's too costly to run it in traditional AWS infrastructure. You have to provision data center locations and try to have automation around that. And all the complexities come with sort of building your own CDN, which is a complex process, and one which, larger entities spend much more, and many more people and many more magnitudes of dollars on as trying to solve that problem. So I think it's definitely the area that gets a lot of attention within how we think about scaling our service.
Okay. And then finally, a question from the audience. Somebody said, I'm running into issues where my client needs me to stream to a third-party platform, but they don't take RTMP. They only support HTTP or HTTPS URLs. What options do I have to stream ultra low latency? And Michael, I'll start with you, because you mentioned low latency dash and low latency HLS, but what other options do they have outside of that?
Can't think of many. I mean, there's a nice synergy around it too, because it consolidates against that CMAF format, and that can also, if you persist that to disk, that can be your live to VOD flow, and it works with traditional. I mean, protocols are nice because they are widely supported, right? And these are streaming standards and protocols that benefit from that standardization. Like, you can just point to Apple client at that HLS URL and you got it. Or if you want to slice it, start at a certain segment or anything, there's sort of standards for doing all these things that kind of make it nice versus trying to do something else. I mean, I know there's like HEVC is one that's come out through the Theo folks, for example, if you were really looking.
HEFP.
Yeah, sorry, I probably said it wrong. I don't remember what it is, but yeah, there are some other standards coming out for, and I guess probably some of the other low latency proprietary providers have their own little solutions, but I think it gets really complicated to roll that out if you have to bake in your own players, and then you can't put it on Apple TV easily or Chromecast easily, or all these different environments that we have to target today. So I think standards really win out here.
Okay, got it. Andy, Ryan, want to add to that?
If I understood, you want to use HTTP as a contribution protocol to ingest into a service, I would highly not recommend that. So that's just not a good workflow. So you're using a latent protocol to be your contribution protocol. That really isn't you really need to go back to the source and find a better contribution protocol for that workflow is the reality of it.
Well, I interpreted it as sort of a syndication format, right? Like that you would be ultimately controlling the end state URL, but yeah, contribution makes no sense for HTTP-based protocols.
Well, and it does seem like this person's between a rock and a hard place, because RTMP would be what you would typically use to contribute, and having to be forced to doing HTTP sort of is counterintuitive, I think is a nice way to say it. So
you need to match up you need to make sure that your equipment from the encoder side is going to match up with wherever you're sending it to, which I had an issue one time where this organization I used encoders with for a long time came out with a new encoder. So it was the latest and greatest. So we're going to go with that. Sort of just assumed that RTMP would be included with that encoder, but it wasn't. And then it just turned into an absolute mess from there, because what was receiving the video was not compatible with what was sending the video. And, a lot of time spent trying to tweak things, and it just never worked. And we just had to basically do it over.
Yeah, it's a good point. We accept RTMP as an ingest, but you need to tweak RTMP encoding settings on any encoder you're on. Remove B frames as an example. That's a must, as well as some other tweaks to make sure that the buffer is low and so on. Because we don't re-encode the video, so we need to make sure it's done in the right for delivery to the end user.
So Ryan, what about digital rights management? I mean, we talked about authentication on the user side, but DRM, and clearly you're doing a live. So, you may see those as sort of two sides of the same coin, but how does DRM come into play?
So let me take it a step further, because this goes back to the whole universal translator, transmuxer that adds value and translates from RTMP to HLS, for example, right? So at the origin server level, at the WAUs level, at the MUX level, at the people, that's where the DRM is getting added. And the DRM is, obviously working with the encryption keys, and then it's doing in the client. There's this triangle in between media server, client, and encryption. I'm going to argue again, that's a broken model. For there to be true content protection, it needs to be encrypted at source and need to be decrypted at playback. It means you need to remove the need for an origin server. So this is part of why keeping something in one protocol end-to-end is so key. Like DRM, there's a rights management piece as far as monetizing your content. That's not really what I'm talking about. I'm talking more about the security and privacy level of encrypting something end-to-end. I think the reality is when we can get to the point where we're doing SVC, scalable video coding, inside of WebRTC,
right,
then we can get the ABR type behavior without ever having to actually create the mezzanine file at the origin level, which means we can have all the benefits of ABR while still retaining encryption point to point. That is a revolutionary thing that's never been done in streaming or video, and I think is going to completely change the industry.
The acronym that comes to mind is MBR, with Windows Media multi-bit rate. But ultimately, yeah, what you're saying is, by carrying it through in that one single protocol and transport stream, you can not only encrypt the content, but obviously encrypt the
right.
The
we're trying to replicate what we were doing with RTMP 15 years ago. Doing simulcast MBR.
Right.
But without the additional encodes. This is a great thing about SVC is you have that one high quality, and because of the technology of SVC, you're not having to add any additional overhead on the bit rate. That's the amazing technology that really is going to send.
You're right. You do it at the highest level, and then you can call out to lower levels as people.
And it's the viewer node that ends up doing the intelligent delivery to the end viewer.
Right. Exactly. All right. We have 2 minutes left. There was one question somebody asked that I would love to answer around music and performances with remote artists. I will just say this, having worked a lot in that space, go check out something like jacktrip.org. There are actually some really interesting technologies going on there. That comes out of Stanford and the university out in Italy. But with that, let's go ahead and just go around. And Michael, I'll start with you first. Thank you very much for being on the panel. Do you have any final thoughts or comments you want to add?
No, great panel. Thanks for having me. Exciting technology developments here.
Good deal. Andy, what about you?
No, thanks for having me as well. And I think, like everybody's been talking about today, is you really need to, before you just jump into a specific solution, you need to figure out what your requirements are and what you're trying to accomplish, and how low does the latency actually need to be, and then make intelligent decisions based on that. And there's a lot of great providers out there that can do it if you need really low latency.
Good deal. And Ryan, being the sponsor, you get the final word. Anything else you'd like to add?
We're working a ton with remote artists, people trying to build this new virtual experience. I think people want to go capture the value that's outside of live experiences. I think there's so many ways to do that. Also, like Taylor Swift just came out with this movie of how she did her newest album in remote from her studio, trying to collaborate with other artists around the world. I think there are these new workflows. Avid is investing this with Pro Tools. Adobe is investing this with BuyingFrame.io. We want to create synchronous collaboration tools, and that can be at the content production side or at the distribution side. And I think that's quite compelling.
Nice. All right. Thank you. Eric, back to you.
Thank you, everyone. Great discussion as always. And we'll see at Streaming Media East what has changed between now and then when it comes to latency. Thanks again, Tim, for doing such a great job moderating and fielding so many great questions from the audience. Speaking of the audience, the winner of our Amazon gift card is Jeremy Raymer. Congrats, and look for an email from us probably next week regarding that. Thanks again to our sponsors, Millicast, for sponsoring this panel, and Bird Dog and Harmonic for sponsoring the whole week. Join us again in about 30 minutes when we're going to be talking about Next Gen TV, ATSC 3.0. Hope to see you then. Bye.